Good evening, dear students. Last class we discussed about the ferric chloride and water system. Ferric chloride and water system. In today's class, I am going to discuss about the sodium potassium system. Sodium potassium system. This is also important for your examination. The 5 to 6 marks, 4 marks or 5 marks or 6 marks. You ask 5 marks or it is 6 marks. This is important. The sodium and potassium. In last class, the ferric chloride and water system undergoes the congruent melting point. It's our congruent melting point. This is an example for incongruent melting point. This system, the sodium and potassium system, this is an example for incongruent melting points. Okay, here this the sodium and potassium, a system or a compound is said to possesses a incongruent melting point. You write first point here, a system or you in bracket you write a compound is said to possesses incongruent melting point. It decomposes much below its melting point or form a new solid phase. You know the solid is formed, you are freezing your mixture, the solid is formed, solid formation takes place. Next, it get a particular point and then it form a new solid here. The new solid phase is formed and a solution having a different composition, but in congruent melting point here the same composition here. The same composition you increases the some temperature here. The same composition in the same composition it melts in the same composition. It is in a solidification takes place in a solid phase. That is known as congruent melting point. Here in congruent melting point, in a solution the different composition from the solid state. In a different composition in a solid state, it may be represented as here. The formation is original solid and new solid solution melt. It represents this type here. Original solid to form new solid plus solution. This is a melt. These are the forming mode. This is original solid. And formation in particular point it form a new solid and solution in melt. These three phases are present in a some particular point here. This represent like this type here. Next, the decomposition at this temperature. This here, the decomposition of at this temperature is called the transition reaction or peritectic reaction. I already told the peritectic reaction or a transition reaction. The sodium potassium system belongs to this category here. The sodium and potassium belongs to this category. This category means this is a incongruent melting points here. It decomposes. The reaction is known as a peritectic reaction or a transition reaction here. And these two solids, one is the sodium and one is the potassium. The solid sodium and potassium, the melting points of the sodium is on 97.8 degrees Celsius. The sodium melting point 97.8 degrees Celsius and potassium is a 63 degree Celsius, that is 63.2 degree Celsius. These are the melting point of the sodium and potassium here respectively. And here the two metals combined together in the ratio of 2 is to 1. Here these two metals, one is sodium, one is a potassium, these two are combined together in a ratio 2 is to 1 and forming the new solid. Here the new solid we forming in the ratio 2 is to 1. The ratio 2 is to 1 here. The sodium is new solid is here Na2, yes, sorry, Na2, okay. New solid Na2K. This is 2, Na2, 2 is to 1. K. It is combined reaction to form a new solid Na2K here. Thus the compound being, this compound being unstable decomposes at 70 degrees Celsius. It decomposes at 70 degrees Celsius here, and this system consists of 4 phases. Here the system consists 4 phases. The phase diagram of system, you see the phase diagram. Draw a phase diagram. The 4 phases. One is a sodium is a solid. Second one, potassium is a solid. And formation. Third one is this is solid and this is solid. New solid Na2K, and fourth one is solution. This is third one. Fourth phase is a solution. The sodium and potassium here present here when on solution. These 4 phases are present in a sodium potassium system. One is a solid sodium, another is a solid potassium, another formation is sodium potassium new solid. This is unstable decomposition. Here new solid is formed here. This is the third phase, and fourth one is a solution. In solution presence of this sodium and potassium in solution are replaced by the melt. These 4 phases are present in a sodium potassium system. Here the pressure is not affect, the pressure no effect on equilibrium here because of the reduced phase rule equation can be used in the sodium and potassium. Here the pressure is negligible because it is pressure not affecting equilibrium. Only 4 phases are present. One vapor is present in this sodium and potassium system. You know, the reduced gives reduced phase rule equation f dash is equals to c minus p plus 1. This f dash is equals to c minus p plus 1. This is a reduced phase rule equation using the two component system here. Next, the phase diagram. Phase diagram. Phase diagram. Phase diagram. Sodium potassium system. According to this phase diagram system, you can explain the curves, points, areas of this system. This is the composition, and this is the temperature. Here K is 100% and Na is 0%. This K is 0% and sodium is 100%. This point is A point and this is this is a x1 and x1 dash. This is the y1 and this is this point on this curve. This is a x1 dash. And here this is a point. Here this is a x point, this is a y, and this is a x dash. This is the C point C. Here presence of solid K and solid K plus Na2K. The presence of solid K. Here Na2K solid. This point is D and this point is B. You practice this diagram 2 to 3 4 times, 2 to 3 times or 4 times. It is very easy to explain this phase diagram or any phase diagram. You take ferric chloride and water system or one component system, water system, sulfur system, and two component system, lead silver system, and ferric chloride system, and this potassium, sodium and potassium system. You know phase diagram and easily explain this system, any of the system. Here, this is the E, this is I here, and this is G. This is H. Here present solid Na plus melt, and here present solid Na, here present in this solid Na plus Na2, Na2K is also a solid, and here is solid, this solid. Here the solid K plus melt, solid K plus melt. This point is G and this point is K and this point is L. So here this point is A and this is C, this is D and this is B, this is E, I, H, this is G, this is F and this is J, this is K, this is L. And here there is presence of solid K plus melt and here presence of solid sodium plus Na2K, sodium, potassium, solid. As sodium, potassium, solid is formed. Here solid Na plus melt. This area solid K, this area solid Na. This here also melt is present, here also melt. That solution is present in this region, in this areas. And here the below solid K plus Na2K is solid. Na2K solid is new solid is present here below this freezing point. And this is the melting point of this is here, or it is the fusion curve. It represents the depression of freezing point curve. This AC curve. Alright, here the point, the freezing point of here, the 60 sodium and potassium. Here the potassium is 63.8 Here this point 63.8 or 63.2 degrees Celsius, that 97.8. This point is 97.8 degrees Celsius. 97.8 degrees Celsius. You know already how to explain the curves, points, areas of this phase diagram. For phase diagram, you can consider first curves and points and areas. Here, the first point I taken first point or first curve at AC curve. First curve is here, curve is, you know, curve AC here, it represents the curve of depression in freezing point. Depression in freezing point of potassium by adding increase of amount of sodium. Here the presence of here solid K, already the solid K is present. The presence of in melt the sodium ion, potassium in melt is given a high temperature and it is a melt state and the liquid phase, and you are decreasing the point. Your point is here, you are decreasing slowly, it gradually decreases. This point is reaches at this curve the A point, and here the A point reaches, you are adding here the sodium. When sodium is adding, the amount the increase the adding sodium amount of sodium here until the lower point C is reached. At this point, you are gradually decreases and you are changing the air composition, and here finally it will reach at the point C here. This point C. Okay, at this point you are reaches, and then the potassium separates out here. Also the potassium separates out along this curve here. Potassium, that is a new solid Na2K. New solid separates out along this curve. At the point C, a new phase Na2K separates out. At this point, the Na2K, the solid sodium, potassium, new solid separates out. The equilibrium along this curve. This is the equilibrium point along this curve. Equilibrium takes place. The curve may be at. It is represented as, it is a transition here. The potassium, the in equilibrium melt here. The presence of potassium and melt. It is here according to this curve. According to this curve, the solid potassium and melt is present. According to this curve, the applying the reduced phase rule, C minus P plus 1. Here F dash equals to, here you know already component is 2. One is sodium component, another is a potassium. Here two species are present. In chemical situation, you have to write the two components. The presence of two components, this is into minus P. Here two phases. Here along this curve, the solid is separating out. Here the potassium is separates out, and you are adding the sodium. Gradually it decreases. When adding sodium, it is a freezing. It freezes. The solid is separates out. The potassium solid is separates out, and also presents the melt. That is the sodium potassium melt is present. There are two phases are present here. And number is 2 plus 1. Here the degree of freedom, it is equals to minus 2 plus 2 and only plus 1 here. Along this curve is a monovariant in nature. Here the system is a univariant. Along this curve, along this AC curve, it is a univariant. The system is a univariant. And next, this point reaches at this point and here there are three phases are present. The three phases are present. Here CD, one is the degree of freedom f dash equals to, here C is a 2 minus P is a 3 plus 1. Here 2 plus 1, 3 minus 3 is equals to 0. Here when equilibrium takes place, it is f dash equals to 0. This is known as the eutectic reaction, peritectic reaction. This is known as a transition reaction. It decomposes the transition equilibrium. There are three phases when this curve is reaches at the C point and the solid, new solid is separates out and another K solid is present and another melt is present. There are three phases and degree of freedom is 0, and along this point in this system is a non-variant in nature or it is a zero variant in nature. And next, second curve C, this one, curve C, second one. Curve CD. Here CD, this curve, you are increasing the temperature. Here this composition it changes and temperature is also changing here. Here you are increasing temperature. Here the solid is next coming into liquid state. The presence of solid states it is converting. The disappearance of here the solid state. It is formation here. The curve CD, this is the fusion curve of the compound Na2K. This is fusion curve of Na2 and K. Okay, Na2K and solid Na2K. This is a disodium, potassium, and melt are in equilibrium along this curve. And here the presence of only here, not potassium is present here. The potassium is disappears here. You are here. This curve is a fusion curve. This curve is a freezing point curve. This curve is a freezing point curve and this curve is a fusion curve. And here there are two solid states. Here these two phases. At this point, two solid phase, one melt is present. So you are increasing here. The curve is going along this and this direction, and here the presence of along this curve, the presence of two phases. One is a this Na2K, another is a melt. You are going to reach this point, this solid potassium is disappears. Here presence of two phases along this CD curve, you know that two phases are present, the F dash is equals to 1. This system is along this curve, this system is univariant or monovariant in nature. Next, the compound, whereas in case of here, the compound has with a congruent melting point, the curve may be extended or it is extended to the stable melting point E. Here you are presence. If presence of it is a congruent melting point and this point is here extended. Here this is the melting point. Here if the presence of here you extending here the point E, it is going to here. This is not possible here. Only presence of is up to CD curve. Here the point gets here. The two here the along this curve two phases are present. Along this the presence of three phases at equilibrium state. Next, this is F dash is equals to 1. This curve also F dash is equals to 1. Next, Third one, curve BD. This one DD or PD. Curve B or B. Curve BD. Okay, here the curve BD. This is the fusion curve. Here also you are increasing the temperature. This is a fusion curve. It represents here fusion curve of sodium. This is presence of sodium. Here fusion curve of sodium. It represents the depression in freezing point. Here you are. This is a 97.8 degrees Celsius. The sodium is a solid state. Sodium. When the sodium and the potassium is melted in state at this point, you are gradually decreasing here. The freezing takes place here, depression in freezing point here. The freezes in a Peritectic using a Peritectic method here. This point is decreasing when this is you have the point some points here. You take a here point and you decreasing gradually decreases here. The freezing takes place here. The when reaches this point and reaches this curve, the solid they start solid separating out. The solid sodium separating out and presence of melt here. This curve, this BD curve also the monovariant in nature. F dash is here also. F dash is equals to 1. This is a monovariant in nature. Here the one is solid sodium is present along this equilibrium, along this curve, equilibrium state. Along this curve is a equilibrium state, and this curve is in a equilibrium state. Here at this equilibrium, the presence of one is a solid sodium, another is a melt, and here along this curve, along this BD curve, the degree of freedom is 1. Here this system, along this system is also monovariant in nature. Okay, next, this system is a monovariant in nature, or this curve is a monovariant or a univariant in nature. And next, effect of cooling. Effect of cooling, effect of you consider the AC curve. Your AC curve at the point X. According to this, I already explained here. This is explained. You take an X point here at AC curve. You take AC curve. A point X is taken in the melt. This is a melt here. This is a melt or in a liquid state. This is a melt state or sodium potassium in a liquid state. Here this melt state you take an X point here. If you cool this point is cooling gradually here. You find there is no change in the composition. You are cooling here, the cooling takes place. Here the composition is not changes. Here there is no change in composition. When attached or it reach this point at this curve, you reaching this curve, you changes the composition here. At this point, the composition till the point x dash here. Here x dash, point x dash, here point x1 dash. Okay, this is the x dash till the point x dash is reached, and after this point it follows the path along this curve. It follows the path the x dash c. Here this is a x dash c, not a xy. Not a xy. If the path along the direction is going along this point, if this point is reaches or attached to this point, and if this point, this curve is the path going to path according to s dash c, not a xy, because of here the composition is changing. Here the composition is changes, and here the solid potassium is here separating out at this point. The sodium is separating out. The percentage of this is decreases, and here it attaches in here. This solid is separating out. The composition is decreasing. Here solid potassium decreases and sodium increases. Sodium the melt composition increases. Here this is solid and the solid potassium percentage is decreases because of it is a separating takes place here, and at which the xy, which means that the composition changes along the curve x dash c. Also the formation of Na2x. Here the formation is Na2x. The new solid is formed here, a new compound is formed here, Na2k, and placed at the point C. At point C here, the new solid is formed here. Because of this is the following path is x dash c here. Next, it is similarly it is considered on B point here, the B point here x1, the melt area you consider this point x1 dash, and here you are gradually decreasing here, decreasing at attention reaches at this curve, and it will not follow the x1 y1 path, it is followed by the this x1 dash c. Here the x1 dash c path is followed on a melt. It is because of the composition is changes. Here it is no change in composition up to attaching or reaching this point here, and then it is melt till the point x1 dash. Here next where solid sodium gets separated, here solid potassium gets separated, and here solid sodium is gets separated, and the state path x1 y1, the state path x1 y1 is not followed, and it is followed the D is represented, it is a incongruent melting point, and this point is represented as incongruent melting point. In ferric chloride and water system consider this the congruent melting point, and here this is incongruent melting point. The D represents the incongruent melting point, and these are the effect of coolings. When you are cooling the curve here, what happens here? This is the effect of cooling. Next points. Okay, next point A and B. Here the point A and B, I already told the point A and B represents the melting points of K, that is solid, and sodium. Here the liquid potassium is equilibrium with solid potassium, and whereas liquid sodium in equilibrium with solid sodium. Here A solid and B solid is equilibrium takes place. The melting point of sodium AB represents the melting point of sodium and potassium. Here the melting point of sodium is a 97.8 degrees Celsius, and here the melting point of this potassium is a 63.2 degrees Celsius. This is the point A and B. Right after this curve, afterwards, effect of cooling. Effect of cooling. Next points. Next points. First point A and B, and second point here C, point C. I explained already this point C. Here point C is the eutectic point. This is a eutectic point. Here the sodium potassium system. Here three phases, namely solid K and Na2K. Another is a melt. Here solid K, Na2K, and melt. Here this represent C is a solid K. Is equilibrium at solid Na2K, and it is equivalent that melt. When the sodium potassium it is a solution takes place here. Okay, here the phases are three phases are present. The reduced phase rule, the F dash dt variable, the presence of degree of freedom is 0. Here at this point, F dash is equals to 0. Next point. Here curve is completed, and effect of cooling is completed. Next, the point A B completed, point C is completed. Next point here, according to point D, it represents the incongruent melting point. This is a incongruent melting point. Incongruent melting point. This is the incongruent melting point. The system this is a take a 70 degrees Celsius. This is at 70 degree Celsius, and it is the sodium. It is a unstable sodium Na2K decomposes to give sodium ion melt. It is also a peritectic point or a peritectic reaction or a transition reaction. Here the phases are three. Here also the phases are three present, and here f dash is equals to 0. Here the degree of freedom is 0 here. Next, the system is, zero variant or non-variant, or it is this area, or it is a the D is a peritectic point. Next, areas. Up to here the points is completed. Next, areas. Here areas. First area AC or ACF. Sorry, take this area ACF. This is a first area ACF. In area ACF, presence of solid K plus melt. Here the two phases are present, and the phase present in this area solid K and melt, and two phases are present according to ACF. First one ACF. Here the degree of freedom F dash is equals to 1. Okay, this is a univariant in nature. The system is a univariant. This area is a univariant. Next, second area BDH. Second area BDH. Here, see here BDH. This one. This BDH. Here also two phases are present. One is a solid sodium, another is a melt, and here also this is a invariant in nature. Two phases are present. That is a invariant in nature or a monovariant in nature. And next, another area below FCG. Below FCG, this area, this one. Presence of this is a below FCG. Presence of here two phases are present. Two phases are present here also. Right hand one below FCG. Here also F dash is equals to 1. Degree of freedom is 1. This is a univariant or monovariant in nature. Presence of here one is solid K and another is a solid Na2K, solid sodium potassium. Next area, that is IHLK. Here this one. Fourth one IHLK. This one IHLK. This. Here also presence of two. One is a solid sodium, and here solid K is present. Here solid sodium and Na2K solid. New compound is present. Here also degree of freedom is F dash is equals to 1. Two phases are present, two component system, and degree of freedom is 1. This system, this area is a univariant or monovariant in nature. Next, the area above AC, the area above ACDB. Fifth one, the area above this A, C, and D, this one above this area, you know, here only, here this one area only, this one A, C, D, B is a only monovariant. Here presence of only single phase. Here the two phases, according to this area two phases, according to this area two phases. The ACF is a two phases. Here this B, D, H is a two phases. I, H, L, K is a two phases. Below FCZ is a two phases. Above ACDB is a single phase is present, and this is a bivariant image only above the ACDB. Here this F dash is equals to 2. Here only single phase in melt state, only single phase is present. Here you write here F, I write here F dash is equals to C minus P plus 1 is equals to 2 component system minus 1. Only this area is present, only one phase plus 1 here plus 1 minus 1 here F dash is equals to 2.